Hello, this is Emad Mirabi. This is the first session of a course called Chemistry and Physics Core Topics. We're going to cover the core topics of chemistry and physics, which are usually taught in 8th and 9th grade in school. So, the topics covered in this session are the atomic structure, the atomic number, mass number, isotopes, ions, average atomic mass, and Bohr atomic model. Okay, let's start with a review about what we know inside the atom, or what is the atom structure. Atom is fundamental building block of matter. What we know about major subatomic particles are these that we know. We have proton, neutron, and electron inside every atom. Proton has a positive charge. Neutron, as the name dictates, it is neutral, so it has no charge. Electron has a negative charge. What do we know about location of these subatomic particles? Proton and neutron are inside the nucleus. An electron is out of the nucleus. The place where electrons are inside the electron cloud, which is somewhere around the nucleus. What about the mass? The mass of proton and neutron are almost the same. They are called one unit, or they are called one atomic mass unit, and the electron's mass is negligible with respect to the other two nucleon. It is 1 over 1837 U, which is 1 over 2000th of U, roughly. So one proton, the mass of one proton or one neutron is roughly 2000 times the mass of electron. So that's why we say electron's mass is negligible, and the total mass of an atom is inside the nucleus. So the nucleus contains the whole mass of an atom. So this figure showing where the nucleus is and where electrons are. Nucleus is dense, a very dense place. So all the protons and neutrons are inside the nucleus, but electrons move around the nucleus. Okay. Nucleus is dense central region of atom, contains essentially all of the atom's mass. What is atomic number? Atomic number, which is denoted by Z, is the number of protons in the nucleus. Each element has a different atomic number. The atomic number identifies the elements. So what distinguishes an element from the other is the atomic number. For example, oxygen has a different atomic number than nitrogen. And nitrogen has a different atomic number than, for example, carbon. The different species or different elements have different atomic numbers. Okay, what is the isotope? What is the definition of isotope? Atoms of the same elements that have different masses. Isotopes have different masses because they have different number of neutrons. Okay, here is an example of isotopes of hydrogen. And the first figure, we see protium, which is the nucleus of simple hydrogen. The nucleus of simple hydrogen has only one proton, and an isotope of hydrogen is called deuterium. Deuterium has 1 proton and 1 neutron. Here the orange ball representing neutron. And tritium has 1 proton and 2 neutron. So the nuclei of 3 isotopes of hydrogen are shown here. If we want to show these 3 isotopes of a hydrogen with symbols, it will be shown like this: hydrogen 1 1. This is the atomic number. Atomic number is usually written here. It is called also Z, and then here it is atomic mass. Atomic mass is usually represented by A. The Z equals to P, which is the number of protons. The atomic mass equals protons plus neutrons. Okay, and then in the case of deuterium, deuterium has 1 proton but 2 nucleons. And these 2 nucleons is 1 proton and 1 neutron. So it is deuterium is represented like this, and tritium is represented like this, 1 and 3. So by subtracting 3 by 1, or by subtracting 1 from 3, we can find 2, which is the number of neutrons. As you know, A minus Z gives the number of neutrons. Okay, what is mass number? Mass number is the number of protons and neutrons in the nucleus. As we talked about it, it is usually denoted by the capital A, and it is shown left hand side, left above the symbol of elements. Okay, the isotopes of a particular element have different mass numbers. So hydrogen has 1 proton and 1 electron. Deuterium has 2 nucleons and 1 electron. And tritium, as we talked, it has 1 proton and 2 neutron in the nucleus and 1 electron again. So the mass number of all of them is 1. This is what identifies this element, all of them, to be hydrogen, but they are different in mass number, which makes them isotopes to each other. So hydrogen has a mass number of 1, deuterium has a mass number of 2, and tritium has a mass number of 3. You can write the mass number of isotope 2 ways. Write the name of symbol of the element followed by a hyphen and the mass number. For example, hydrogen 1 or H1, hydrogen 2 or H2. This is how we showed an isotope. Carbon 12 or C12, or carbon 13 or C13. Uranium 238, most common isotope of uranium, which has a 99.3% of abundance in nature. This kind of uranium is the most abundant form of uranium in nature. Okay, write the mass number as a subscript to the left of the chemical symbol. As a superscript, write the mass number as a superscript to the left of, so hydrogen 1, hydrogen 2, carbon 12, carbon 14, or uranium 235, fissionable isotope of uranium. And sometimes it is written like this. This form is more common, which is written as a superscript to the left of the chemical symbol. Sometimes the atomic number is added as a subscript. Okay, so in here, to the left down of the symbol, we write down the atomic number. So carbon atomic number is 6, uranium atomic number is 92. Okay, it is better that we memorize the first 20 elements with the symbol and with the atomic number. I'll cover this in the next session. That's what do we need to know about periodic table. Okay, for example, helium 4 isotope. As we know, helium has 2 protons, so atomic number is 2. It has 2 neutrons. The helium 4 isotope has 2 neutrons, so 2 protons and 2 neutrons are in the nucleus, and 2 electrons exist in the first shell or first layer of electron. So number of electrons equals number of protons in neutral atom. For an atom to be neutral, the number of protons must be equal to the number of electrons. Okay, and because helium has 2 protons, it has the helium atom has 2 electrons. Okay, atomic structure. As we talked, helium has an atomic mass of 2, the number of protons in an atom, and the atomic mass of 4. Helium 4 has a mass number of 4, the number of protons and neutrons. 2 electrons. It has also 2 electrons because it has 2 protons. That's it. In a neutral atom, the number of electrons equals the number of protons. Okay, now let's see what are ions and what is the definition of ion. An atom is neutral. It has neither a positive nor a negative charge. In order for an atom to be neutral, the number of electrons must equal to the number of protons. The positive and negative charge cancel each other. If an atom doesn't have the same number of proton and electron, an ion is formed. When an atom loses or gains 1 or more electron, it acquires a net electrical charge and it is called an ion. For example, some ions that we know are, for example, sodium ion. It has a positive charge. It has, as we know, sodium has 11 protons and 12 neutrons, so the mass number is 23. And if we want to write down the number of subatomic particles here, proton has 11. There are 11 protons in this ion. Because it has a positive charge, it means it has lost 1 electron, so it doesn't have an equal number of protons to the electron, but the number of electron is 1 less than the number of protons. So we have 10 electron, and the neutrons, we can subtract these 2 numbers to get the number of neutrons. Another example for oxygen. Let's do it for oxygen 816. As we know, oxygen has an atomic mass of has an atomic number of 8, which means it has 8 proton, and because it has taken 2 electron, or it has gained 2 electron, it's become an ion here, 2 negative ion. So the number of electrons is 10, and the number of neutrons is again can be obtained by subtracting atomic mass and atomic number, which is 16 minus 8, which is 8. Okay, let's continue. Ions have a different number of electrons than the neutral atom. Negative ions have additional electron equal to their charge. For example, oxygen has 8 electrons, but O2 minus has 10 electrons. Why oxygen has 8 electrons? Because oxygen has 8 protons. We need to know that oxygen, atomic number of oxygen is 8, as I told you, we need to memorize the first 20 elements of periodic table. I'll explain it more in next session. So O2 minus has 10 electrons. Let's continue with the rest. Positive ions have fewer electrons equal to their charge. For example, aluminium has 3 electrons because atomic number of aluminium is 3. But aluminium ion, which is aluminium 3 plus, has 10 electrons because when the charge is 3 plus, it means it has lost 3 electrons. Okay, let's do some practice problems. List out the number of protons, electrons, and neutrons. So as we learned, the number of proton is the atomic number here is 82. The number of neutrons can be obtained by subtracting atomic mass and atomic number, which is 125. And then because it's a neutral atom, the number of electrons equals to the number of protons. So it will be 82. So the number of electrons will be 82. But if it was an ion, the number of electrons would be different from the number of protons. Okay, in the case of an ion here we have, again we want to list out the number of protons and neutrons and electrons. Number of protons is 25 here. It is the atomic number. And the number of neutrons is gained by subtracting the two numbers there, which is 30, and then for electron, this time electron is not equal to the number of proton, but electron is 2 less, so we have 23 electron here, because when we have a positive charge, it means we have more proton than electron, so the whole charge is positive. Okay. The next question says atom of a certain isotope have 73 neutron and mass of 123. So let me write the data. Number of neutron is 73. Mass of 123. So mass number, which is neutron plus proton, is 123. So from here we understand that the number of proton must be 50. We can find this number by subtracting the two numbers. Part A is saying what is the atomic number. Atomic number is the number of protons, which is 50. How many electrons are there? Because it's a neutral atom, the number of electrons equals the number of protons, which is 50.